Solve by elimination. 3x minus 2y equals 6, and 2y minus 3x equals 6. One thing to notice here is that the second equation isn't in the same standard form that the first equation is. In fact, all of the equations that we've seen with elimination have had the x term first and the y term second. We're going to want to rearrange them so that everything lines up when we perform the elimination. So I'm going to rewrite the second one as negative 3x plus 2y equals 6. By putting the x term first and the y term second, and then the constant on the other side, we can make sure that everything lines up properly. Now at this point, we can line up the two equations because we notice that we will have some cancellation. So I'm going to take the other equation, 3x minus 2y equals 6, and stack it underneath that first one that we have. And then let's go through and add them together. Negative 3x plus 3x is going to be 0. Those cancel because they're opposites. However, 2y and negative 2y are also opposites, so they're also going to cancel. And that's going to leave us with 0 on the left-hand side of the equation. When everything cancels, we are left with 0. On the right-hand side, if we add, 6 plus 6 equals 12. And so when we perform the elimination, we're left with 0 equals 12. Now this is a false equation. And we've seen a situation like this before when we used substitution. When we used substitution, a false equation told us that if we were to graph those lines, we'd have two parallel lines, and they never intersect. And because they never intersect, we know there is no solution. And so just like with substitution, when we're solving a problem with elimination, if the variables cancel and we're left with a false equation, we can conclude that there is no solution. And that's our final answer.